going to take a little break from the network mapper, because in order to continue with that, we need some way of simulating a network. So we have something to port scan when we use the tool. So that's what we're going to do today. We're going to create a network simulator which allocates a lot of IP addresses, and it will create dummy services on different TCP ports, and it will send some data when you connect to it. So like an SSH version and stuff like that. So this will be, you should always select the easiest code language for the assignment at hand. So I could code this in C, but that would be a rather advanced and big project. So in this case, I think I will be able to write it quite easily in Linux Shellscript, Bash. So that's what I'm going to do. But before we start with the network simulation project, I just want to add a little thing to our network mapper, because we finished the naive version, pretty much finished it anyway, but there's one thing that I forgot to do. So let me just connect to my screen at CodePlanet. And this is 369, I believe. No, that's not it. 250 perhaps. Yes, this is the one. Alright, so what we have this far is this code, which basically connects to different IP addresses at different at a specific port, and reports the header from that port. But when it logs the IP address, it gives us, let's see, where is it? It gives us this format. So it shows the IP address in hex and in network byte order. And that's because we do have a library function which is called inetAddress, which takes a IP address in the dotted decimal type, and it creates a number out of it. But we do not have a function which does the opposite, which takes this number and returns a string. So that is what we are going to build. It's not a very huge function. And after that we will create our network simulator. So this is one of the functions that I have written many times, and I have needed to rewrite it in several projects due to my copy-paste rule, which is never to copy-paste. So we will rewrite it last time, but I will do it inside of the context of Birch utils. And if you remember, that is my library, where I will put all the different functions that I plan to reuse in different projects. And this is an example of that. So let's code this thing, and let me just make some room. And what should we call this function? Well, it will return an int8 pointer, so our string, and the other function in the other direction is called inetAddress, but we can't really just shift that. Let's call it to_dotted, because this format is called dotted decimal type, or dotted decimal format. So to_dotted would be a good enough name. And the only thing we're going to give this is an inetAddress t with the IP address in a number format, and also in what's it called, network byte order. And that basically means that you are sending the most significant, the most important bits first when you send it over the wire, for example. Right, so let's create the function definition right away so we don't forget. It's called to dotted, and we have an in address t, like so. Okay, so how do we do this? We're gonna have to do some binary operations. So basically, if we have something like 10, 0, 0, 1, this in a numbered hex format will be something like 0, 1, 0, 0, 0, 0, 10. Something like this, I believe. Let's just add something temporary to our code. So let's do let's just do like this. So let's print f0x%x, and then we take the inet address of argv1, like so, and return 0. And if we make this project, we should be able to just run our program with 10, 0, 0, 1. And yeah, basically the same. Let's see. The initial 0 didn't show up here, but as you can see, so this 10, that is 0A, because A is 10 in hex. And then we have 2 zeros, so this is basically like this, 0, 0, 0, 0, and then, okay, so this is what it is. And then we have a 10. So basically we just need to take these 4 parts and put it into a variable using binary bit operators. And it's usually a little tricky to get it to work. Sometimes it takes a couple of tries, but let's go for it. So what do we have? We need a couple of int 8s, A, B, C, and D. And this will correspond to, if we have this number, this will be D, D, C, C, B, B, and A, A. So this A should contain the rightmost of this hex string, which will be the leftmost of these. Alright, so how do we do that? First, we need to select what we want to extract. So let's begin by extracting those 2 DDs. Let's see. Yeah. And you do that by creating a mask. So you select something by putting F. And if you convert this to binary, there are zeros and ones, and the ones select, which means that we need this whole DD thing, and then it will be the maximum number, which is FF. And the rest will simply be zeros, like this. So 1, 2, 1, 2, 1, 2. So this basically means that those things that corresponds to these zeros, which are all these ones, will not be copied over. But since we have the f's here, this will be copied over. Which basically means that after the operation, we will have 0 dd, and the rest will be zeros like this. So that's our step 1. Let's do that. So we'll set d equal to, and then we will take the IP address, and we will use a, let's see, an AND operator, and then we will have the mask. So that will be 0x and then ff, and then we have 1, 2, 3 double zeros. This means that d at this point should be equal to this. Or rather, this parenthesis is equal to this. This d is only an int 8, so it can't hold all of this. So the next step is to remove these zeros, because these hex addresses, the lowest number is the most to the right. So what we want to achieve is having something which is a 00, 00, 00, and then the dd. So we want to push this dd all the way to the right. And these zeros are optional, which means that the contents of the d variable will be this dd thing. And that fits perfectly fine inside of an int 8. So basically, let's create another parenthesis, and we will use this operator in order to shift all the bits to the right. And we want to shift them 24 bits, because a 00 in this case is a byte, and a byte is 8 bits, and we have 3 of those. 3 times 8 is 24, and that's why we move them like this. And if this works, we should be able to extract the 1. So if this works, this should be equal to the number of 1. So let's do like this, and let's just verify that it works. Because if this works, it will be quite easy to take care of the other parts of the IP address. Let's see. So we want to call, instead of just inet address, we want to call to dotted, and we want to send the inet address of argv1, like so. And we need to recompile the library as well. This one, make k. Yeah, we need to have an include. In address t syssocket.h. I don't think we need this string, by the way. Parameter names without types. Without types. In function declaration. parameter names without types in a function declaration. This is a type, this is a type. What's it saying? Is it because we have the function declarations above the declarations? Int 8, int 8. That's weird. Did it upload correctly? virtuetools.h 2-dotted stdio syssocket.h. syssocket.h. Why do we still get that error? Unknown type name in address T. Let's copy some of the other socket related includes then from netmap.h. So perhaps we need these two as well. Okay, so now it compiles. Unused variables I don't care too much about. And now the first thing didn't error out either. Okay. Alright, so let's see if this one compiles. Yes, it did. And if we run it, if we did everything right, we should get a 1 as output. And we did. Worked at the first try almost, which is kind of great since this is kind of advanced stuff. But now everything will be easy. We will just do the same, but changing the mask from this to this, which means we will instead of grabbing the DD or the 1, we will grab the CC and the zeros in this case. So let's remove these lines and we will do C equal to IP and 0x 00 FF 0000 like so. And this time we only need to shift it 16 bits. And then we have the B. And this time we take the IP and the 00000 FF 00 and we shift it 8 bits. And finally we do the A, and now we just do IP and 0FF, and we don't need to shift anything. And we can remove the initial zeros because they are not necessary. So now we have the 4 variables which contain this stuff. And now we just need to generate a string out of that. So let's create let's create a static int 8 buff 16 size, and we zero out the buff, and then we can use smprintf to the buff with a maximum size of 15, and then we just put our, let's see, %d dot %d dot %d dot %d, and then we give the A, B, C, and D. And finally, we simply return the buff, like so. And in this case, we can do printf %s and this. So now we should get back the same IP address that we send, but it has been converted back and forth. Oh, that's quite an error. Different signness, right? So let's see. When we use the smprintf, we need to make this a char. Probably that's the only thing that failed, even though we got a full screen of errors. Almost. Let's see. Output may be truncated. No, it will not. smprintf output between 8 and 16 bytes into a destination of size 15. Well, no. Since we say 15, it will still be okay. I don't like these wordings, actually. In this case, I know perfectly well what I'm doing, and I don't think this is really helpful. This is just annoying. Yeah, so I don't care about this. And let's compile this, and then we run this, and we get the IP address. Very nice. I like when things work first. The first round, or what's it? Okay, so let's remove this stuff. And where do we print out our result from the connection? Is that only in one place? Let's see. If it's connected, it will send to the header, and the header will print it even though it doesn't get any data, right? So instead of this, we will simply do a %s, and then we send this IP address to our 2 dotted. And we do the same in this case when we have an output. So 2 dotted, like that. We save. And we compile. Okay, now what? Top dotted. Well, there we go. And it compiled just fine. So let's try this out then. Let's just echo 127.0.0.1, and let's pipe this to this, and we would run it against port 18 again. And this time we do get the real IP address and the version of this. Perfect. So now our first version of the network mapper is done. So the next step will be to improve, to test and improve the performance of the scanner. But in order to do that, we need to have some network to scan, and that's what we're going to focus on today. So what's coming up next is we're going to begin coding our network simulators. Welcome back. Let's start building this network simulator in Bash. Since I don't want to mess with the IP addresses of my CodePlanet server, I'm gonna connect to a different server. I created a I created a server which I call Intel 32, which is a 32-bit server, and that doesn't really matter in this case, but I want to use this one for our project. And we need one dependency in order to code this, because since I'll be using Bash, which is Linux Shellscript, I need a program to call to modify the IP addresses. And there is a new function, a new command in Linux, which is called IP, which you can use for this purpose, but I feel more comfortable with the old ifconfig thing. So you need to do apt-get install netutils in order to get this ifconfig. So let's see, do I have a code? I have ASM and C. Okay, so let's create a directory which we will call this netsims, and I will set this to my home. And let's create one additional window. C and netsims. So we have one window to code in and one to run the code. And this will be a pretty small project, I think, at least. I hope. So I will be doing this in VI. So let's create netsims.sh. Network simulators. And let's begin by creating a function which we will call fail, which basically will exit everything. So we will be running a couple of not threads but forks, and when we fail we want them to be killed off as well. So we'll simply run kill all. And what do we want to kill? We want to kill, let's see, we're gonna use a program called netcat, so that will be killed off, and we will also end this, I think. And if we are still alive, we want to exit with an exit code, and before that we want to send a message to the screen. To the standard error, and that's why I add this 2 there, because 0 is standard input, 1 is standard output, and this is standard error. Okay, so now we have a fail function. Perhaps we don't need to get any output from this, and if we want to suppress all the output, we can pipe this to dev null, and then we do this. So we take both the standard output and the standard error, and we pipe it everything to this dev null, so we don't get any output except for this exit message. And this function is just to make things a little bit easier. I will also have a usage function. If we supply wrong number of arguments or similar, this will give us the output that we should use. So this will be something like let's see. Maybe I will do I think I'll do it like this. I will run cat and I want to send stuff until we give an end of file, and I want to send this to this, so to standard error. And what do I want to show? I want to do, let's see, usage, and this will be called netsims.sh, and there'll be a couple of different usages, so perhaps we should do something like this. I wonder if we can add a tab like this. Let's try that. And let's do a space as well. So netsims.sh, and let's create a couple of those, because we will be running different types of commands. The first thing will be something like something that initializes all the different IP addresses, or it allocates them. So maybe we should call this alloc, and the arguments for this will be, we need an IP network, IP subnetwork, and we need a number of IP addresses. First IP address, and this will be like this, by the way, because if we don't specify one or both of these, we'll have default values. So the default value for first digit will be, let's see, it'll be a 1, and the number of addresses will be 10. Okay, so this is one of the commands. The other one will be free, and this will basically remove all the IP addresses. And then we will start the simulation. Let's call this simulate. And what do we need to do here? We need a config file. File.conf. And let's add an example for each of those. So let's just do this example. So an example would be 192.168.10.0. First digit will be 10, and number of addresses 15. Maybe we should do the default settings. So and this will simply free all the IP addresses we don't need an example here, and this will should be here. Start the simulation, read config from file format, and this will simply be port number header, port number header. And then we will have an example which will be netsims simulate netsims.conf, something like this. And we will also have example config file contents, and let's connect to port 22 so we can grab one of these headers. And let's take some FTP server. And the thought is that this will randomize so let's say we have 10 IP addresses and we have those two. Each time we will start simulation with one of our IP addresses, we will simply randomize one of the lines from the config file and open this port on that IP address, and when we connect it will show this data. So we need to install Netcat if we don't have that already, which I do. Otherwise I think it's apt-get install NC or perhaps Netcat. Try both if you don't have it. And that's on Debian, by the way. If you're using Red Hat or another Linux distribution, there is another command, but you probably know how to install things already. Otherwise, Google's your friend. Alright, so let's see if this is working. It was a while ago that I did stuff like this in Bash, like input output and those kind of things. So let's see. After we have done this, we wish to fail let's see, cat from EU to this. Yeah, let's remove this empty line, and then we will fail with a 1 and an empty string. Like so. And let's just test this out by running usage. And we need to give this the permissions to run, so change mode 755 netsims, and now it turns green. Perhaps you don't have the colors initialized, but it should get this asterisk to the right. And you only need to set the permissions once per file. And then we simply run it by doing /netsims.sh. Okay, so everything seems to work except for this T kind of thing. So let's replace that. We can create a variable. Let's call it tab, which will be equal to printf, and then the tab, like so. And then I want to replace that thing, so %s, I want to change T to $tab everywhere. Okay, let's try it out. It didn't really jump out. Why not? $tab. Tab equals. Oh, it changed even this. That's why. This should be right. Alright. That looks a little bit better, perhaps. I will not focus too much on this visually. You can give it a little more time and structure it better, but I don't think I want to have tab through on these lines, by the way. Let's remove this like so, and yeah, just the // lines. Because that is kind of the headlines in this case. So that will be, yeah, let's see. Okay, this is good enough, I believe. Alright, so we have the documentation done. Let's start by creating the first function, which will be the allocation function. And if we think about it a little bit, what do we need? For what kind of information do we need in order to create this stuff? Well, if we run sbin-if-config, we see that we have two interfaces. We have the network interface card and we have a loopback interface. So we need to get this interface name, which is basically different on every machine, pretty much. And then we wish to run, we need to create one interface, one sub-interface for each. So the first will be :1, :2, :3, etc. And then we will specify the virtual host IP address that we wish to use. So this is the command that we want to run when we allocate the addresses. So we need to follow the range and increase this once per every one. But first of all, we need to grab the interface. And the input that we give this is the IP subnet. So from the subnet we need to get the address, and that's pretty easy to do. So this is the IP address of the machine, and that means that a 0 at the end will be the network. And if we run the command IP address show and then this network, perhaps we need the CIDR as well. IP address show device IP show I thought this was right. IP address, no, IP route show. Okay, we do need the CIDR as well. So let's edit this. IP subnet / CIDR, and the CIDR is the size of the network. So /24 means it's a 24-bit network, which is basically 256 different IP address combinations. So if we run this command, we will get this output, and the third word is the interface. So let's create a function which returns the interface if we give it a IP subnet and a CIDR. So let's call this grab no, it's too long. Grab IF for interface. So first we need to, no, we don't actually need to break it up. Let's just do IF equal to, and then we run IP route show, and we give the argument to this function. And this is not the IF, this is the output. And then we get the interface by running cat, which divides this string into different words, and we want the third word. And if we do these three signs, operators, we can give this a string to work with, and that is our output, like this. And if that interface is equal to nothing, then we fail no such network. Otherwise, we will simply echo this interface. There's not really a good return function when it comes to strings in Bash, but we can just echo it to the screen and handle it like this in the calling function. So let's try this out. Instead of running usage at this point, we will simply do, let's see. Yeah, let's just do this temporarily. We will only give it one argument, and that is the network at this point. So network equals $1, and the IF will equal our grab IF function supplied with the network. And then we'll simply do something like the device name is IF. So let's try it with a bad IP first. So 1.2.3.4/16. No such network. It still runs the device name. I don't think we need to use exit here. We should, let's see, because we run this failed thing. Exit should do the whole script, I think. Why does it go through with this anyway? Exit the shell, exit shell status n if it is minted. The exit status is that of the last command executed. No such network. The device name is fail to no such network. Hello nc.sims.sh. Still didn't help. Exits a for while or until loop if any specified greater or equal to 1. Suspend, what is that? Suspend shall execution until it receives a sync count signal. Unless forced login shells and shells without job control cannot be suspended. Force to suspend. But this probably pauses it. Kill local logout. It's weird that exit doesn't just exit. And I think the kill command would solve this as well. What if we were to do this instead? Okay, this is good enough, I think. Yeah. All right. So where were we? Yeah, we need to test it with a real IP as well. So what is our real IP to begin with? So the IP is 10.1.2.5, and that means the network is 0. And if we check the net mask, we know that the first 3 fields are set, which means that we have a /24 network. The device name is blah blah blah. Okay, so far so good. So now we get the interface, and now we need to turn this IP network into the first IP address. So let's see. Instead of just doing it like this, we will create a command which will be the first argument, and then we need to, let's see, a select case would be kind of nice here, but I don't remember the syntax. Help select. So select name in words. Do. It would be beneficial to have an example. Case word in pattern commands and then double. Okay, I think I can do this. So let's see. Case seemed to know which order is it. Doesn't matter. Word in. Where is the code? This should be closed, and here we are. Okay, so case our first command is alloc, case alloc in cmd. And then there should be a parenthesis. And then the commands key. cmd like this. And then we want to run the alloc function. We don't want to send the command, but we do want to send the network. Let's see. The network and the digit and the addresses potentially. So let's just do this, and then we break. And then we are done with this case. And the next case is case pattern blah 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 commands. Commands, then we have this, and then a couple of dots. So then we have another of this, I think. Separate multiple patterns. So look in keyword in, and then we have pattern, we have commands. Let's do a quick Google in this case. Case bash. I just need to see an example. Okay, case expression in pattern 1 and this, and then the statement, and then that. And then we do the next pattern. So we don't write case expression in again. Alright, so I did it in the wrong order then. So it should be case cmd in alloc, and then this should be here, and then the next one right, now I think I know it. Case cmd like so. And then we have something and we probably don't need this break either. And then ESAC at the end. Something like this. And we don't have the alloc command currently. Let's just add something temporarily so we know what's going on. Alloc, like so. And let's see if this even starts. Syntax error near unexpected token, something on 63. 63 is this. Maybe we don't have in again. Case cmd in. And we take this off. Try it again. Okay, nothing. And if we do ABC, nothing. If we do alloc, works. If we do something, test. Alright, so now we have learned something new today. We have learned how to do basically select, but in bash. Alright. Okay, but let's focus on this alloc thing. So we'll make a function for alloc, and we have 3 arguments. The first one is the network. The second one is the first IP. And the third is the number of IPs, amounts of IPs. And if let amounts, if we don't have amounts, then amounts will be equal to 10. And if we don't have first, then we set first to 1. And let's use let here as well, so we are consequential. So let amount equal to 10, amount let first equal to 1 or 2 perhaps, in case we have the first. Yeah, let's do 2. And if we don't have a network, so if network equals to 0, nothing, then we need to fail. Alright, and as you can see, there is different syntax when we compare a string and when we compare an integer. Good to know that. Okay, so now we have all the information that we need. Now we just need to loop through these and create the IP addresses. We also need to see that we are having root access for this command because it is necessary. Actually, that is necessary for all our operations. So let's see, if we run id and we grep the first, let's see, perhaps we can give a switch to this one. Okay, id-u. So let's put that at the top of our program, which is, it's right here. So the UID will be equal to id-u if let UID, which means if this is not 0, then fail root access needed for this tool. Right. So now we can be sure that we are having root access. And now we need to grab the interface. So if equals grab if, and we send the network. We do also need to get the first 3 things from the network. So if we have 10, 1, 2, 0, /24, we want to grab these 3 fields. And let's call them ABC for the A and B and C network. And in order to get these, we need to divide this into dots, and we want the first to the third. And what do we want to send? We want to send the network. And now we can easily construct IP addresses out of this. Right. Perhaps we should figure out our own IP as well. If we do IP address show on ENS 192, what do we get? Okay, we get this. And if we grep this for iNet, and then we, let's see, if we set this, so we're looking at iNet space, and then we want to grab these things, So the thing we set inside of these parentheses is basically what we want to grab, and then there's a space after. We want to change this to \1, which is the first parentheses or the things inside of that. I think this will work. Let's test it. Grep iNet send. Perhaps we need to do this or this. Yeah, we need to take everything else as well. And we don't want the 6 afterwards, so let's do -EV or -E, and we want to have iNet, but it should not be a 6 after, like so. And we want to grab everything before and everything after. iNet, and this parentheses. Why do we get the entire line? I think we should be able to. Everything inside of this parentheses. And what if we were to do this and we add a slash and 2 numbers, or not 2 numbers, it should be 1 or 2 numbers, and an option to S. Let's do this instead, and then we do the cat, and we remove everything after the first word. Okay, there we have it, and then we need to remove the slash as well. Okay, quite a command, huh? But sometimes this is what's necessary. Probably is an easier way, but that'll do for now. So after we have gotten the interface and the network, we can get the own IP. The only thing we need to change is this interface, which will be our IF. So then we have our own IP. And if we don't get it, we shouldn't fail just because of that. So let's just do something of the sort. If own IP equals nothing, then let's just set own IP to something which it cannot be, like an IP address of all 300s, because then it won't mess up the rest of our code if it's an invalid IP address. Alright, so now we have all the parts that we need. Now we're going to create a loop. So let's see. For I in, and we want to do a sequence from, let's see, from first to from first. Okay, so we have the first and we have the amount. We need to calculate the last, so let last equal first plus amount minus 1, right? Because if first is 10 and the amount are 2, then we should do 10 and 11, which means the last in this case will be 10 plus 2 minus 1 equals 11. Yeah. Right. So from first to last, do. And we will create an IP variable which will contain let's see, it will contain the ABC, which is the beginning part of the network. And then our current IP ending digit, which is I. And then we have the IP. And for now, let's just echo those IPs to the screen so we see that everything is working. And let's also do if $IP equals own IP, then echo something like this in phi. Why do I have 2 steps? Alright, we need a done here. And let's just return 0, like so. So if this works, we will be able to print out the IP addresses that we are considering to create. So let's run our tool, and we will give it 10, 1. First we need the command, and the command is allocate. So 10, 1, 2, 0 /24. Our first IP address will be 10, and we want to create 20 of these. Syntax error phi 45. Then root access needed, okay. And there we go. It almost works too perfect. And we also need to have the interface, the sub interface. So let's create a new variable. We set x equal to, let's see, let's begin at 2. And we have the IP, but we also want to have the sub if, which is basically the if followed by a colon followed by the x, like so. And then we can do something like this, and $sub if. Okay, we need to increase it as well. So after the phi, we will do x++. No, let's do else, because we don't want to increase this if it's our own IP, then we will just skip it. So let's tell that skipping. Otherwise, we want to increase x, and then we run phi. Okay, that looks pretty nice. And if we were to run this from the beginning instead, okay, it wants all those. But let's see, if we run it from 1 to 10, then it will identify the own IP address, so we don't overwrite this and create a collision. Okay, so far so good. The only thing we need to add with this command is the ifconfig command in order to actually create all these interfaces. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Welcome back, everyone. Let's continue building this network simulator thing. So, let's see. Before we continue with the next function, I'm going to fix a couple of bugs. As you can see right here, it doesn't really work when giving few arguments. So it should use the default settings in this case. So let's see why that is. I would say it's either because it doesn't quite work when you send several arguments that are empty. I don't think that is the case, but it's one possibility. The other one is it simply doesn't interpret my let lines, these. So perhaps if amount is not 0 but empty, it doesn't evaluate to true when we use this not operator. So let's do something like this. If the amount is equal to nothing, then we will set amount to 0. And if the no, not the first. Yeah, the first. If first is equal to nothing, then we will set first equal to 0 as well. And then it'll trigger these parts, and the default settings should work, I think. So let's try it out. First we will just give it a network. Nope. And this does not work either. Okay, then the problem is the argument list. So let's copy this part. And let's go here. I didn't really want a tab there, I wanted just a space. Like so. Let's do something like first is equal to the, let's see, the third argument. No, the second. No, the third. And then the amount is equal to the fourth argument. Okay, and then we check if amount is nothing, then we set it to 0. If first is nothing, we set first to 0. And in order to make this a little more expressive, I will also do something like network, which is argument 2. And now I'll just give these named variables as arguments. And let's see if this works. Okay, the program starts here. The command is this. And then we have the UID, we check for this stuff. We set network to 2, we set first to 3, we set amount to 4. If amount is nothing, we'll set it to 0. If first is nothing, we'll set first to 0. And then we will call our functions using these arguments. And when we go to the alloc function, we will set network to 1, first to 2, amount to 3. And if amount is 0, then we will set it to 10. And then we go ahead with the rest of the code. I think it's a little bit weird that it doesn't give us an error message or anything. I wonder where it stops. Let's see, does it go all the way here? Yes, it does. What about here? Yes, it does. And what if we were to echo the first and the amount? 5 and 10. What am I missing? Is it something about the network? Seems okay as well. Grab interface, network. Do we get an interface? We do. So that's not it either. And then we extract the IP, we create our own IP. If that is this, we set it to that. Set X to 2, and then we loop between first and last. And what is last? Did we define that? Last. Yeah, right here. Last equals first plus. Okay, that makes sense. So we need to move this down a little bit. Because we can't really use our empty first and amount when we haven't set the variables. So now I believe it should work. Right, so now it defaults to 10 different IP addresses, and it will start with the second IP. And it will jump right past our own IP so we don't collide. One more thing I'd like to add before we go on is we don't want to reuse our own IP, but we don't want to use the default gateway IP either. So if we run IP route show and we run it against a zeroed IP address, then we get the default via and our default gateway. So we do want to skip this one as well, so we don't disconnect us from the internet. So let's see, how can we do that? Let's just copy this whole grab IP block. And let's call this grab gateway. And we'll run IP route show, but in this case we will use a static network. And we want to cut out the 1, 2, 3, the third word. And let's not call it IF, let's call it gateway instead. we want to echo out the gateway like so. And then we'll do a similar thing in our alloc function. So instead of just doing the if, we'll do gateway equals, we want to grab gateway. And let's see, if it's our own IP, we'll do this. Else if IP is equal to gateway, then we want to echo $IP is my default gateway, skipping. Otherwise we want to increase this part. So let's save and let's run this again, but this time we want to start at, let's say, 0, doing 20. And if we scroll up a little bit, no, it did not catch that. Let's do 5 instead, and let's do 1 here. Okay. So this is our default gateway, but we still do 1, 2, 3, 4. I wonder why it didn't do 5. Ah, it always starts at 2. That's not right. But this is the interface. Let's see. IP is equal. Perhaps we shouldn't do I. Yeah, we should do I. And this is increasing the interface. Well, this is okay, by the way. It will simply try to do 10 IPs if we ask it to. And it doesn't necessarily succeed in that endeavor. Right. So at the end here we could type something like no, I think we want to count them. And how do we do that? We should do something like if config-a, or we don't need the a actually. Let's just run this and grep for the interface name, followed by colon, and that's enough. And then we'll just count the lines basically. So let's do this. Num is equal to, and let's use a function count if, and then we give it the interface name, and then we'll simply echo successfully created $num IP addresses, something like that. And we need this function then. So count if is a function, if we don't have, let's do this, if equal to $1, and if $if is empty, then fail, no interface specified. And otherwise we'll create an additional variable which will be the count, and then we'll simply do ifconfig, and we want to grep for, let's see, the interface followed by a colon, and let's count it. Let's do like this so it looks a little bit more structured, and then we'll simply echo out the result, which is a count, return 0, like so. So if we rerun the last command, we should get something like 3 or 4, I guess. 1. That's because we are not currently creating these IP addresses. We are just echoing the result. But these should be okay. 1, 2, 3, 4. No, not 4. Yeah, so it should give us 3 when this is up and running. Okay, so the only thing left for this part of the program is to create a function which actually creates those interfaces. Or maybe we don't even actually need a specific function for that. Let's see. So instead of echoing this, we want to create the interface, and we do that by running 2 commands. First we run ifconfig on the let's see, on the sub-if, and we also need the current IP address, which is IP, and then we need to activate it as well, and then we run the command like this, and we want it in the up state. And that should be it, I think. Let's try it out. Successfully created 4 IP addresses. And if we run the ifconfig command, we see that we have a couple of interfaces with different IP addresses. So let's see if they are actually working. Yes, great. And I recommend, when you do use this in order to create IP addresses like this, only use it on these local IP addresses, not on your public interface, because then if you are unlucky, it will successfully steal those real IP addresses from your internet service provider, and that is not recommended. Alright, so now we can create our IP addresses. That's step 1. Step 2 will be to create our services, but before we do that, I want to create this free function. So let's see, how do we know which interfaces to bring down? It always starts with the number 2, and then it calculates upwards. Right, so we can use our count if, but we do, however, need to give it one argument. We need to give it the interface. Or let's be oh, I don't remember the word now, but let's do it the same way as we did there. So we give it the subnet, and then free all the IP address. Let's do like this. Alright, so we will create another case. A case. No, I don't think we do it like that. I just think we say free like this. And we need the network, which is the second argument. And then we will simply run free. Perhaps we should name it free IP so it doesn't collide with the Unix command free. So free IPs, and we give it the network. And that's it. The only thing we need to do is create the function. So it will be called free IPs. And we have 2 arguments. No, we have 1 argument, and that is the network, which is the first and only. And then we will have the interface that we get by running grab if using the network. And we also need to know how many it is, so the count will be equal to count IP. And then we give it the interface. And if the count is equal to nothing, and the count is equal to 0, and if the count is equal to 0, then we fail. No IPs to move. Otherwise, we need to do a loop. So we know that the first is equal to 2, and the last will be equal to first plus count minus 1. And what else? Don't think there is much else. So let's do a for loop. So for I in the sequence from first to last to, and we're gonna run the sbin ifconfig command. We need to do the sub interface as well. So subif will be equal to the interface followed by the current value of I. And then we'll give ifconfig the sub interface and we'll set it to state down. Done. And we'll just echo something like IP address interfaces brought down. Return 0. Okay, I don't think there's much more than that to do there. So let's run our tool. Oh, okay, this is probably due to the ordering. So let's take this, let's see, this free IPs function. And what exactly did it say? Line 29, free IPs command not found. Forgot the parentheses. And a file for matching 183. Okay, we have this. The case command in that, then we run a couple of things, and then we have those. Then we have this next. Do I have to have space here? Free IPs, network, and then that, and then that. No. Echo test. Network.2. If we give arguments, that is, yeah. Unexpected end of file while looking for matching. So I probably missed a quote somewhere. Let's grep this file for every line with a quote in it. And let's go from the down and upwards and see if we have a matching one at each location. Perhaps we should go in the other direction, because most of the things I added on top of everything. So let's see. Maybe I can create a regexp which searches for anything followed by a quote followed by anything which is not a quote. I think this should find every occasion where there's only one quote, right? No, that did not work. Do I need to escape them? Because I'm looking for any character which is not a quote. Guess I can't do that. What if we were to replace the first quote on every line with, let's do single quote, but only one per line. Let's do this and this. Like that. And then we want to grep for a quote. Okay, so now we get a quote which is single quote first and then the double quote. But we want to find something which does not contain the double quote, right? So let's do -v. Okay, but it still does need to find the single quote. And there we go. Some grade A troubleshooting, don't you think? So let's see. This is probably somewhere in the loop we created just now. So inside of free IPs we have a loop. Right, this should not be a quote, this should be a parenthesis. And now everything should work. Okay, we need to be root. And we need to be able to spell sudo. Okay, no error this time, but we don't get any output. How is that possible? Because, let's see, case command in. Maybe we never add that. I wonder if there's some kind of default thing to use when using the case. Exit status. What if we were to just create something like this? And in that case we run the usage. Is that possible? Nope. What if we don't use the quotes? There we go. Okay, so we do have a couple of interfaces now, right? Which means we should be able to remove them by running free, and we need the IP network. So let's see. Oh. So this is the network. And we will run free, and we give it the network like this. No IP, count IP command not found. What did we call it? Count IF, alright. Let's try again. Cannot assign requested address. Let's create an echo here instead so we see a little bit what's happening. Isn't that right command? Maybe it has changed somehow. Up, down. And this is the, let's see, interface, up, down, interface, options. This is exactly what I did, right? All aliases are deleted. Okay, so that's it. Then this became much easier, actually. Let's see. Let's comment this out in case we need this code later on. Well, the IF we still need. The count we don't need. We don't need first, we don't need last, we don't need a loop. And the sub IF will always be 0. And this is it, I think. Yeah, and we can remove the echo part. Let's see, IP address interface is brought down. We got an error, but it worked. So in case that will happen again, let's just type this to dev null. Okay, so 2 out of our 3 commands are done. The only thing we have left is the simulate command. And all that will take is a config file. So let's replace this something with simulate. And we will set the config to second argument. And we will run simulate with that config. And all we need now is a function for the simulate command. And that is what we'll do next. Okay guys, let's finish this thing, shall we? So let's see. Okay, there's an error somewhere. Line 8. That's because I have an empty function. Let's just return 0 for now. And we need to be root. Alright, so we have done the allocation function and free function. All that is left is this simulate function. So the first thing we will create is a config file. Let's call this netsims.conf. And the format of this file will be pretty self-explanatory. 2 different arguments per line. The first will be the port number, and the second will be the header. So if we continue with the same example as before, so let's take these 2 lines and edit the config file. Just paste them in. So at each line we'll give a TCP port number, space, and then we'll give the header text, which will be displayed once we connect. And every time, or once for every IP address, a random line of this file will be selected, and that will be bound to the actual IP address. So we will use the nc command, the netcat command, and usually when I run this, I use this format and then a port. We will not need the double V, because that's only verbose information, and that's not necessary in our case. L means listen, so we listen on a TCP socket, and P is the port, 21 in this case. But I do also need to add something to bind it to a specific IP address. Sorry. So let's see. I hope that is possible. Yes, local source address. So we need to add the -s as well. So let's see. Let's create a function called netcat, and this will take an IP, and it will take a port, and it will take a header. And I'll put this inside of quotes because it might be several words. And we need all of these 3, so let's see if Yeah, let's do it like this. If this is nothing, then we will fail by saying bad formatting config file. Otherwise, we will craft a command, and this will be netcat, and we want to be listening on the port, and we also wish to use the source IP of IP, and we want to send the header like so, and we want this to be running in the background, but first of all we want it to doesn't display any output, so let's pipe it to dev-null and both standard error and standard output, and we want it to be running as a fork in the background. So let's put this inside of parentheses and put an and sign at the end, which will make it fork into the background. And that's it. So using this helper function, it will be easier to configure everything. So let's see, this simulate command, what kind of arguments do we need? We only need one argument, and that is the config file. So let's make sure that we have that. So let's just do config equals to this, and if that config file is empty, then we fail. No config file specified. And let's check if that file exists as well. I think we do that by else if -e config. So if it exists, and we want the opposite of this, right? Something like this. It's been a while since I coded these conditionals, but let's try it out. In that case, we want to fail with unable to open config file, like so. Let's copy this line and let's set config equal to netsims.conf, and let's change this to our regular if. Okay, we did not get any output. If we were to search for conf2 instead, then we get it. Alright, so we did it correctly. Alright, so we need a function to grab a random line from the config file as well. So let's call this grab line. And in order to grab the line, we need to parse a file and figure out how many lines there is in this file. So let's start there. In order to do that, we need a variable. So let's call this lines, and we are going to cat the config file, or we don't need to use cat, by the way. Let's grep the config file. And what do we want to grep for? Well, we do not want, let's add big E so we can do advanced regular expressions, and then a small v, which means that we inverse the grep. So we look for everything except what we specify. And what do we want to specify? Well, let me just check something out. If we were to do echo, couple of spaces, blah blah, and we do grep dash e blah, then we get this line. What if we were to, I'm not sure, but I think there is backslash w for white space. Let's see if that works. And if we weren't having any white space, it still greps. What if we do this? And if we do that? No, that's not it. And regex and regular expressions. Okay, what if we search for Z and search for white space? Nope. And grep perhaps. So big and small W, white, followed by space with or without, or I mean the word space with or without the space. There we go, white space. Characters are white space, no. Okay, in this instance, I think we need to go to Google actually. So let's see. Regex white space. All this white space. Most common form of white space are the space, the tab, the new line. We have to match only the lines that have a space between the list number and ABC. We can do that by using the expression D and S. To match the number, the actual period, one or more white space characters. So S is white space. Okay. That kind of makes sense. So where were we? Close down that window. Oh wait, let's do it again. So echo space space blah blah, and we want to grep dash e, and this time we have a white space and we have the blah, and we get it. But if we remove the white space, we do not get it. All right. So in our case, we want to have a couple of white spaces and then a hashtag. So one or more white spaces and then a hashtag. We get it with this one. We should also get it with this. No, we don't actually. Let's put a star here instead. Okay, it worked there. and it works there. And if we were to remove this, we don't get it. Okay, now we have what we need. So we want to grep for, let's see, what we want to remove. So at the beginning of the line, this means the beginning of the line, there can be one or more, 0 or more white spaces, followed by a hashtag, which makes it a comment. And then we can have anything and the end of the line. If we find this, we want to remove it. But if we do not, every line which does not contain this, we wanted to, we do also want to remove, let's see, empty lines. So only the start and the end. And we want to grep this from the config file. Let's see, we need to supply the config file. Config equals $1. I don't need any error handling in this case because I'll be just repeating myself. The error handling is here instead. Alright, so we grep this from the config, and then we'll simply count the lines. So if it contains 2 lines, then lines will be equal to 2. And if lines is empty, then we'll set lines to 0. And if lines are 0, then we can't really do anything. So fail. Sorry. Bad format in config file, like so. But if it works, then we have the lines. Now we need to select one of these lines. So let's see, if we have 2 lines, we want to create a random number between 1 and 2. So basically we do that by specifying let rnd equal to random percent lines, and let's put this inside of a parenthesis. That's probably not needed, but let's do it anyway. And then we +1, because in this case this line will produce, this part of the line will produce a number between 0 and 1. So it always becomes one less than lines and starting at 0. So if we take this and add 1, we will produce either 1 or 2 in this case. So now we just need to grab that line from the file, and the easiest way to do that in Bash is by doing something like this. Let's call this line, and let's just we will take the head of the file, starting at the line number, the random number, and let's see, this is from our config, and then we'll take the last one. So let's see, if we have line A, line B, line C, and line D, and our random number is 2, then the first part of the command will grab these starting at the second line, and this part will take. The tail isn't really the right way. Let's see. No, we should do another head. So the first part will be this one, and then we take the first line of these 3, which translates to the second line. Alright, now I think it's good. And now we need to break this up into the different parts. So the first part is the port, which is just to cut the first word from the line. And when we have done that, we need to take the rest, and that'll be our header. And we'll just do the reverse. We will cut words again, delimited by spaces, but this time we will begin with the second field and take the rest of it. I think this is right. Let's try it out. So if we cut this, config file, and let's take the first line. No, not that. I think I did it correctly from the beginning, actually. This should be tail. Or should it? Head -2, head -8. No. Yeah, the head -2 takes the first 2 lines. Right. Okay, so I did it correctly from the beginning. This should be tail. Alright. So -2, -1. Yeah, this should be tail. Okay, so from this we want to grab the port number, that's no problem, and the rest, no problem. Okay. And how do we return this in an easy enough kind of way? Let's see. Well, we could just do this. So take the port and then a pipe sign and then the header. Because this is a little bit easier to parse, since it's rather unusual that the header contains a pipe sign, but it could. So maybe we should just do this instead. The only thing we need to do in this function is actually echoing the line, and then we can parse this in the calling function instead. Okay, so now we can simply get one line by using grab line and the config file. And when we simulate, we need to run a loop the same number of times as we have IP addresses. So let's get a line first, and we'll just do grab line config, and we also need to know the count, so count if, but in that case we will need to know the we would need to know the network here as well. Alright, easy enough to fix. So netsim, so there's simulate, and we will add IP subnet /cider. This is also, no, this is the example. So here we'll have 192, 168, 0, 24, like so, and here is the syntax. So let's add IP subnet /cider. We need the file as well. Okay. And let's add the tab here as well. Alright. So now we only need to create a loop and start all the instances of the services. Okay guys, let's finish the last couple of things with our network simulator. Before we continue writing the simulation function, I need to fix something which I kind of forgot before. Our netcat function, which runs the netcat tool, and it opens the TCP connections and stuff. If we leave the code like this, that basically means that once we have connected to the service and disconnected, this netcat instance will terminate. So basically we will need to make a loop out of this. So let's do something like while true, do sleep 1. So at each iteration we will sleep 1 second, and then we will start this service. And then we're done. And this will be repeating itself in its own thread until we use the fail function, which will kill off all of these threads or forks. Perhaps we should be calling them processes, because that's the best way to describe it. Alright? So let's see where we were. We are inside of the simulate function, and we have grabbed a line from the config file. We have counted the interfaces. So the next step would be to go through each interface, which means go through every IP address, and then we will simply launch the services. So let's see, before we do that, there were something I wanted to add. What was that? Can't remember right now. Let's do that later. Let's see what the no, I wanted to add an additional command so we can stop the services. So let's see. We'll simply do, if we say stop, then we'll simply run the fail command with a 0 and the stopped message. And that's all. Let's add it to the usage as well. So let's see. So we have simulate and we have netsims.sh stop. We don't really need any additional commands, parameters I mean. So stop all the simulation. Oh, I mixed it up a little bit. These two lines should be right here. So and now I remember what I wanted to add. Since we are using a tab right here in the example config file, maybe the users will just copy paste these two lines and use them, and then it will not work because of these tabs and spaces. So let's just modify the grab line command, and let's remove the white spaces in the beginning. So let's see how to do that easily. I think we can just pipe this to sed. So we will do sed, and we will search for, let's see, spaces. No, it needs to be in the beginning. So start on the line, and then one or more spaces. We need to add the command, which is S for search and replace. And we wish to replace it with nothing globally. I think this will work. Right. Let's test the grab line function. So if we run alloc free simulate. So if you run simulate instead of this simulate command, we will simply do grab line and provide the config. And then I will comment this out for the time being. Alright, so let's edit this config file. And let's add both a tab and a space like it is in the output. let's just do it like this. And then we run netsims and simulate netsims.conf 39. Yeah, we are unexpected. Oh wait, no, let's see, we have a parenthesis, then we have these single quotes, and inside of that we don't have anything which should mess up anything, and then we pipe this to sud, and we have the single quotes surrounding. Looks right. And there we have this. If let lines, then let RND line equals. Here it is. I forgot the parentheses. The error messages when coding bash isn't always that informative. We need root. Okay, that didn't quite work. It did not remove the white spaces. Why is that? Perhaps we need to use the -e flag to gain access to the more advanced irregular expressions. No, that's not it either. Probably this plus then. I always have trouble with this plus. Let's do a star instead. Nope, not that either. Okay, let's check through this line. What do? We search for the beginning of the line, and then white space, any number of them. We replace it with nothing globally. Maybe we need some kind of ending thing right here. So the next character will be a number, and we need to grab that number using a parenthesis. And then we will simply replace everything to that number so we don't lose it. Does this work? Annoying thing. Let's just echo this string for now. And now we probably have spaces here because I copy-pasted it. But that should also work, right? Wait a second. This is the line number of lines calculation. This is not where we should be doing this. that explains it. So let's remove this stuff that we added while troubleshooting. Let's put this plus back and let's copy the string. My connection is a little bit slow today. I'm connected using a mobile internet device. So let's see, line equals this, tail this, and right here we want our Z. Alright, still doesn't work, but we're probably closer to a solution this time. So save. Let's try again. Yeah, there we go. And what if we do the different spaces and stuff? And we pipe this to the same thing. Also works. Alright, great. So now that it's fixed, let's go back to this stuff and remove the grab line and add the simulate back. And let's finish this simulate function if we are able to find it. There we go. Okay, so we have grabbed a line, we have counted the interfaces, and so let's see, if we have one interface, it will begin at interface number 2. So let's see, let's do like this, by the way. If count is equal to nothing, then let count is equal to 0, and if count is 0, then fail. And if you wonder why I do this in 2 steps and don't just put the code right here, that is because if it is 0, then I want this, and if it's empty, I want both. So let's see, I don't really remember what error number we are at. You need to run Sims alloc first. 5. And now we will simply increase the count, like so. No, wait a second. Let's not do that. Because if we have 5 interfaces, we will get 5. So that means we will start with number 2, and we will end with 2, 3, 4, 5, number 6. Alright. So let's create 2 more variables. Let's see. Start equals 2, and let end equal, let's see, count plus 1, right? Or should it be 2? I need to check this. So let's see, we have, let's call it just int 2, int 3, and int 4. So in this case, we will return that count is 3. So it'll start at 2, and it'll end at count plus 1. Or count plus 1. Right, so let's do a loop. So for I in the sequence of start to end, do. And what are we going to do? Well, we need to create an IP address, or we need to grab that address from that interface. How can we do that in an easy enough kind of way? So let's see. The interface is on one line and the IP is on the next. That makes it tougher. But if we give the interface as an argument, then we will only see that interface. And then if we grab inet, for example, or more specifically, we grab inet which is not followed by 6, then we get the correct line. Alright. And then we can just do, can we do it like this? No, there are white lines and stuff. We can use awk in this case. That is a quite advanced scripting language. Let's see if I remember how to do this. I think we just do something like this. So we want to print the first, the second. Okay. I think it should be just this. Yeah. Because when you use awk to print words, it will ignore these initial white lines, and it will also handle tab a little bit better than cut does. So if cut doesn't cut it, then we will go to awk. And the $2 in this case is simply the words number, so the second word. Right, so let's set the interface to this, and we'll remove this and change it to, no, we'll do like this, if, and this will be the IP. So the interface, that will simply be the let's see. Did we grab the interface? Because we do need to know that, right? What argument does it take? Let's see. Netsim simulate, and then we get the IP address and then the config. But we never really added that. So let's do it. So the, what did we call this before? I want to use this network. The network is the first argument of these. So we run simulate with the network and the config. So the config is the second argument, the network is the first, and we will get the interface using grab if in this network. And then we will change the name of this if to sub-if like we did before. And we have the base if here, and then we need the current number, which is $I. And if you wonder why I put this in curly braces, I don't think it's really necessary in this case, but if you have one variable and another variable, I don't want bash to mess them up, mix them together or anything, so I usually do this in that case. So let's see. So now we have the sub interface, and from that we get the IP address. What else do we need for this netcat function? We need the IP, we need the port, and we need the header. So we need to parse the let's see. It's getting tougher and tougher to find our way in this file. Alright, so let's see, line equals count equals. This line thingy I will move inside of the loop because it'll change each time. And from that line we will get two things. We'll get the port by simply cutting out the first word. From the line, and we'll get the header by cutting out the rest. So F2 and forward from the line. And now we have everything that we need, I think. So what we'll run is netcat, and I think it was IP and port and header. And maybe we should put header inside of quote because it can be several words. Yeah, that'll do it, I think. And then we end the loop. And instead of running netcat, let's echo netcat, so we know how it works. Let's do this. For the time being. Alright, have we forgotten anything? How does netcat work? We'll get IP, port, and header. And then we start a loop where we first sleep a second, then we launch netcat, pipe to the header, and the output is sent to dev null, and we will fork this into background. Perhaps we should have some kind of message. Launching service at IP and port. something like that. Alright, let's see if this will work. So let's run our script, and let's begin by creating a couple of IP addresses. So we will base it on this. And let's see. Alloc IP first digit number of addresses. So this is the network, and we need to, let's create from number 6 and 10 forward. And we need to add the command alloc. Okay, created 11 IP addresses. 11, that's one too many. That should not happen, I believe. So, let's see. Alloc. We go from first to last. And last is first plus amount minus 1. So first in this case is 6 plus the amount, that's 16. Maybe we should do minus 2 here instead. But what if we only want to create one interface? Then last will be 6 plus 1, which is 7, minus 2, which is 5. So it will go from 6 to... let's leave it like this. It's not... You can do it as an exercise and see if you can fix that in a way which doesn't create additional bugs. Let me just check one thing. One, two, three, 4, 5, 6. Oh wait, 11, 12, 13, 14, 15 is the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It did create 10 IP addresses. The counter is wrong, right? Yeah. Good we didn't change this part. Okay, so how do we are printing out num. And what is num? Num is count if. How can that be? How does count if work? It runs if config, it greps for the interface with a colon after, and it counts them, right? So let's count them manually first, so we see that we are right. This first one is not... Aha! There is a colon after this anyway. That's a little bit annoying. Let's add one more thing to this. We want to have an extended grep so we can use better regular expressions, and this should be followed by a number, right? So let's free the IP addresses of this network. And what was it? 10.1.2 10.1.2.0/24. Ten one two 10.1.2. Maybe it takes a little while. Where is our free function? Here it is. Okay, so what do we do? Sub-IF is the interface with a 0, and we want to take it down. But that doesn't seem to work anymore. It did work before. Let's try combining these two methods then. Let's see. If count is nothing, then count is 0. No IPs to remove. So let start is equal to 2, let end is equal to, what did we say, count minus 1, and for I in sequence from start to end, do, and then we simply want to create our sub-IF, which will be the IF followed by the number, and we'll run sbin if config sub-IF down to dev like this. Done. And then we remove the 0 interface. And maybe we shouldn't give a success message unless we are sure. Right. And the last thing we wrote, the simul function, I think I might have forgotten something in that loop. Yes, we need to have the dollar signs here. Like so. And let's see if we can take this down. That seems free, and this is the network. Okay, now it works. Great. So let's go back and recreate our interfaces, and this time it should give us 10 IPs, right? And did we get them? We did. And now let's see if we can, yes, we need root, if we can simulate. So instead of alloc, we do simulate. And the network is the same, but we need to give the config file, like so. And if this worked, it will simply print the call to the function, so we know it gives the right arguments and stuff. No interface specified. That seems simulate, and then the IP network. No interface specified. Where do we have that? No network. Here, and where are we? We are in the alloc function. Why do we get into the alloc function? Maybe we have the same message somewhere else. No? Did we do a mistake somewhere here? So we have free, we have simulate. The only thing that differs is that we don't have a new line after these, but that can't be it, right? So we have simul, we have free, we have a lock. Why does that happen? And what if we do this? Then we get the usage. Case command in alloc, free, simul, let me try something. Okay, so it so it does run this command, simulate network config, and if we go to the simulate function, network is 1, config is 2, grab IF. Network 1, config 2, interface, grab IF network. No config file, unable to open config file. That's a weird error, isn't it? It's like it runs the wrong function. What if we put the echo 234 right here? Okay, it does go here. Network is 1, config is 2, IF, grab IF network. Let's add a couple of echoes every here and then. And let's jump it out a bit so it's easier to remove afterwards. Count IF. We do need to specify VIF as well. Alright, that makes sense. Let's remove this And let's try this again. Okay, something happened. We ran netcat against this IP, and we did, however, not remove this line. So we need to fix that. And we have port 22, we have the header. Looks right, except for it not removing this stuff. So why doesn't it? It must be the grab line function. What are we looking for here? We are removing everything that begins with no, wait a second. If it begins with a hashtag followed by anything or an empty line, we don't use that. Maybe we are overcomplicating this. What if we just do that? No, that didn't help. Because we are looking for 0 or more white spaces, then this. Maybe we shouldn't escape it. Still there. Oh, we are editing the wrong function again. Or I mean the wrong line. This is the place. So the line let's see. We should take out a random line, but we need to remove that stuff first. So let's begin with a grep instead, exactly like we do here, and then we head that and tail that and set it. Right? So now I think it should work. Yeah, we get 21, we get 22 and the input, but nothing else. Alright, so let's try if this really works now. So instead of just echoing our results, we will actually run this netcat command. And let's replace this to double quotes. Let's save and let's see how it goes. Okay guys, welcome back to the last part of this episode. Let's try this out and see if it works. So let's start the simulation on our network with our two services. And let's see what happens. Launching service at. This looks kind of good. Let's see if it's running in the background. Let's grep for NetSims. Yes, and let's grep for netcat. And let's check for open TCP ports. Looks right. And let's see if we do get a banner if we connect to any of these. So let's take these, open a new window, and paste them in, and let's take one in the middle. And let's simply connect to that IP address. And the 10 was port 22, like so. And we do get the output we thought. If we were to quit this and we connect once again, we get the same. That's pretty that's pretty nice. So let's see, let's try one of the other ones. Maybe the first. No, let's try one port 21. So let's do this one at port 21. And we get the other banner. This is great. Let's try out our port scanner and see what happens. So let's see. Let's detach from this window and connect directly to CodePlanet. And let's launch our, I think it's the, is it the 250? Yeah. So let's run our network mapper against the start IP of, I don't remember really which one it was. That was the first one. I think number 6. And let's run all the way towards 20. And we also need to specify the port, so let's do 22. And let's see what happens. This is rather slow, so I'm not sure if it's gonna freeze if we're not able to connect. I'm not really sure about my firewall settings either, but let's see what happens. Let's run this in the background and double check the IP addresses. So let's see, what did we have? This should be open on port 22, right? Let's connect manually from the same server. Let's see. If we go to CodePlanet and we connect to this one at port 22, we do get the banner. So let's reattach our screen. But we haven't received any output as of yet. Why is that? let's run this using strace so we get a little bit more information. Okay, so it connects against this IP 11. Did I misspell the IP address? Or is it a bug? What happens if we do 9 instead? Eleven 1 2 6. Why is that? It seems we are okay, that's right. We are increasing the IP address, but we are using network byte order, so we are increasing it at the wrong end. Okay, so basically if we were to manually specify the IP addresses we wanted to scan, so if we make a simple for loop, for I in the sequence of 6 to 20, do echo, this should be 10, and this should be the I, and done, then we get this. If we were to take these IP addresses and we'll pipe them to our network mapper at port 22. Okay, then it works. So basically we need to fix that by turning the IP address back to, let's see, we need to turn it back into the regular byte order, then increase it, and then turn it back. But that will be a question for the next episode when we continue coding our network mapper. As of now, it works. The port scanner works when we specify the IP addresses manually on the standard input. And more importantly for this episode, our network simulator works perfectly. So let's see if the rest works as well, if we are able to stop this as well. So let's see if we run netsims as root and we do netsims stop. Is it still running? Crap, netsims. That didn't quite work. So the stop command, where does it run? It runs the fail command. And what exactly does the fail command do? Usage, here we go. So we run kill all netcat netsims. We should probably do -9 here as well. Yeah. Alright, let's try it again. Netsim stop, boom. And if we grep for netsims, how can it survive a... Let's see. kill all-9, probably because it's looking for bash and not netsims. Is it possible to do like this? That's pretty weird. I don't have the kill all command. I've never seen that before. Kill all command missing. Alright, so let's apt cache search for kill all. Okay, let's try this one first. Apt-get update. Right, it's running real slow because I haven't fixed my bad router. I hope this package is rather small. Because if the apt-get update takes this long, a huge package would take even longer, but it shouldn't be that big, right? It's almost done. That's pretty weird that they don't ship the kill all command by default. That's one of the most useful commands, I think. Perhaps there's some kind of replacement in later Linux distributions, but I don't really see why that is necessary. A lot of packages. Come on. Come on, come on, come on. Come on, come on, come on, come on. There we go. Right, so we do sudo apt-get install, and we try this one first. Okay, doesn't seem very big. The machine itself isn't very fast either. Perhaps I should give it a little more priority. But I don't use this specific machine all that much because this is the 32-bit version. And I basically only use this when I need to code assembly. Alright, do we have kill all? We do have kill all. Good. So let's remove the 9 for now. And let's rerun the netsim stop command. Alright. And let's grep for netsims. Okay, it's not running. What about netcat? Not running either. Good. So we still have the IP address is right. So let's see if we can remove those. We need to take the network and let's see. We run free and we paste in the network address and the CIDR, like so. And hopefully, if everything works as intended, we will not have all these IP aliases anymore. We don't. All right. Thank you, ladies and gentlemen. We have produced a full-fledged network simulator only coding the Linux Shellscript of Bash. And the final version is 274 lines of code. If you like this episode and you want to continue watching, then please like and subscribe, and you will get a notification when my next episode is released. It's usually every 4th day or so. Don't forget that we have a chat that you can visit. Check the community page for that. You're always welcome to come in there and ask me stuff. If I don't answer directly, I'm not at my computer. But if you just idle in there, I will answer you when I get back. So thanks for watching, and thanks for today.